Hi, and welcome to this new section of this course about unsupervised learning, which will teach you how to mine patterns in high-dimensional data. Pattern mining consists of using and developing data mining algorithms to discover interesting, unexpected, and useful patterns in your data. There will be different topics we will cover to reach the goal of this section. In this first video, we will introduce you to the subject of pattern mining with market basket analysis for transactional data. We will introduce the concepts and the algorithm that we will be using throughout this section. Then, in the second video, we will see how to compute the item sets using this algorithm. And in the last section, we will try to make more sense of the computed item sets by using relevant visualization tools. In this video, we will try to bring you a global overview of the market basket analysis for transactional data using the online retail dataset that we already used in section 1 and 2. First, we will see what actually is market basket analysis. Then, we will see how we define the purchasing rules and what is the pertaining algorithm. After that, we will see what are the measures to analyze the association rules, and finally, we will introduce the analysis using our online retail dataset. Market basket analysis, or in short, MBA, is an association rule method that identifies associations in transactional data. It is a modeling technique based on the fact that if you buy a certain group of items, then you are more or less likely to buy another group of items. This is actually the basis of cross-selling, which is a practice of selling an additional product to an existing customer. And indeed, as acquiring new customers has become difficult with the increased competition on the market, businesses have to enhance their revenues from their existing clients. For example, if we find out that customers who buy product X and product Y together will in general also buy the product Z, then it will be useful to place these three products together in the store in order to maximize their sales. When two or more products are purchased, MBA is done to check whether the purchase of one product increases the likelihood of the purchase of other products. It is an unsupervised machine learning technique used for knowledge discovery rather than prediction, since there is no target variable provided by such data. The market basket analysis results in a set of association rules that allow to identify patterns of relationships among items. Recall the online retail dataset that we have been using along this course, for example in section 2 to build the Kmeans algorithm. So here you could show some parts of video 2, section 2, for example, where we see the description variable in the data frame, or just the word clouds, for example. So we have the description variable from which we can retrieve words that we can use to define the product. The rule can typically be expressed in this form. So the first rule states that if two products with cake and paper in their description are purchased, then another product with party in its description is likely to be purchased. The second rule states that if two products with pink and heart in their description are purchased, then another product with Christmas in its description is likely to be purchased, etc., etc. The a priori algorithm is used for mining frequent item sets and relevant association rules. This algorithm utilizes a simple prior belief about the properties of frequent items, and this is why it is called a priori. Using this a priori belief, all subsets of frequent items must also be frequent. This makes it possible to limit the number of rules to search for. There are basically two statistical measures that can be used to determine whether or not a rule is deemed interesting. Let's define the general rule of purchasing Y when we know that X has been purchased. First, the support measures how frequently this item set occurs in the data. That is the probability of purchasing both X and Y. Then, the confidence measures the algorithm's predictive power. It is calculated as the support of item X and Y divided by the support of item X. It is actually the probability of Y conditional to X. As you can see in the below table for products A, B, C, D, the confidence of purchasing A after C is not the same as the confidence of purchasing C after A, because the denominator will change in the formula. A practical solution to the problem of finding too many association rules satisfying the support and confidence constraints can be tackled by using a popular measure, the lift, which can be interpreted as the deviation of the support of the rule in the numerator from the support expected under independence given the supports of X and Y, that is the multiplication of the respective supports of X and Y. We will now apply the market basket analysis on the online retail dataset example. As we have seen in section 1 and 2, this dataset is not easy to use because it is very huge, about 500,000 observations, and it has to be preprocessed, for example using text mining, as we did in the second video of section 2, in order to retrieve better insights about the products. Using this online retail dataset, we will see how the a priori algorithm works in the next video, before highlighting some visualization tools available in the R language. Now, let's quickly dive into the R code. So, in this video, we will just introduce the subject because we do not have a lot of time. We will continue the analysis during the next videos. So for this video, we will only use the tidyverse package as usual. First, we have to load the final online retail dataset that we have created and saved during the 5th video of the first section after some data pre-processing. For example, we have removed the duplicated and the missing values. So you can see this full dataset with the invoice number, the stock code, the description, the quantity, the invoice date, the unit price, customer ID, country, day of week, hour of the day, and the total price. So these last features that we have created during the 5th video of the first section. And you might have a look at this video of section 1, where we computed some useful visualizations of this dataset. Then it is useful to know what is the distribution of the number of items purchased per customer. So we take our data online final dataset that we group by customer ID, and we compute the mean of the quantities by customer. And then with this dataset, we filter so that we have all the quantities less than 100, and we make an histogram of this data. And we put the number of beans to 500, for example, so that we can see something. Yeah, because as you can see, some customers have purchased in average a lot. And we can see that with the same code, but now arranged by descending order of average number of items purchased per customer. And we can see that 2 customers purchased on average more than 10,000. Then we are interested to see what are the best sellers in the database. So we compute the number of counts for each combination of stock code and description. And we keep only the descriptions that were purchased at least 1000 times. Then we order it in the ggplot and we flip the coordinates so that it will be easier to read the descriptions, as you will see. Indeed. So by keeping only the products that were purchased at least 1000 times, we are left with 12 products with the white hanging hurt tea light holder product which has been purchased more than 2000 times. But we know that we have some big customers that purchased a lot of products. So one could wonder if this product could have been purchased only by a few big customers. So we group the data frame by customer and we filter so that we keep only the best seller. Then we count the number of times the customers purchased it and we sort the data frame by this descending count. And we can see that no customer purchased this item a very large number of times, maximum 33, which is reasonably small. Moreover, 856 different customers purchased this item. And that represents actually nearly 20% of the total number of customers.